Hi, in this video I'm going to show how to control an Elegoo robot with an Android phone using Simulink code generation. So I'm going to give a brief through the setup. Basically, we have an Arduino based Elegoo robot that has controllers for the wheels and also has an ultrasonic sensor. So the ultrasonic sensor distance, which is going to give you the distance between the robot and any colliding object, is going to be sent through the serial cable to the Android phone. And the Android phone is going to tell the Arduino to the same serial port where to go forward, backward, stop, left, or right. And then the Arduino is going to take those instructions and apply the corresponding controller commands for the wheels. And you might wonder why making this more complicated, because the Arduino can do all that simple algorithm to traverse the house with a ultrasonic sonar. Well, this could be a start for something more advanced, because the Android phone has more computational capability than the Arduino. It has more sensors. It has a high resolution camera. You can easily implement a convolutional neural network computer vision algorithm inside of it. You can use the accelerometers, other sensors that the Android has, and also the computational capability can also be used to speak or listen to somebody, have a conversation with an individual that the robot might find along the way. So yeah, the algorithm is simple. The robot's gonna go forward if it doesn't see a wall, and if it sees a wall, then it's gonna go randomly left and right. So I'm gonna show you a little bit of how that goes. So it's going forward because there's no walls. It finds a wall and it's gonna go randomly left and right until it doesn't find a wall, and then keep going forward. Okay, I'm gonna show the models for this. First, I'm gonna go through the Arduino model. This is to control the robot, and basically to deploy the generic code of this model, you just have to click in here. But first, you have to install the Arduino support package, connect your USB cable from the computer to the robot, and that USB cable is provided by the Elegoo robot. So yeah, once you have that connection and the Arduino support package, it's a matter of deploying it, clicking here. So it's gonna compile it, run it, and install it into the Arduino controller. So in here you can see that we have three blocks from Arduino support package. One of them is the serial communication, and in here we're gonna receive the command coming from the Android, and that will be one of these values. It's an unsigned integer, so we only need 1 byte for this. So 0 is stop, 1 is moving forward, 2 backward, 3 left, 4 right, and 5 turning on the LED, but we don't use that in here. So yeah, so the port number is 0 on sign integrate. This is important to always have the data types matching, otherwise you're gonna have problems. And the data length is 1 and sample time is 0.1. I'm using sample time of 0.1 in both models. The Arduino model and the Android model are using sample time of 0.1 discrete. Okay, so that command is gonna go in here, and here is where you control the wheels. And this is the ultrasonic sensor block. So there's a special block for that in the Arduino support package. It's called Arduino ultrasonic sensor. For the case of the Elegoo Arduino, you're going to receive the ultrasonic sensor data in pins number 19 and 18. So you have to set these two in here and put the sample time in here, 0.1, the same of the model. Okay, so I'm gonna multiply it by 10 just to amplify it. I'm gonna put a clamp, a maximum and minimum limit. And then notice that it's coming out as a double, so you have to cast it down to assign integer 8. I learned this, I had some time debugging this, but then I realized that I had to have the same type so you can fall into the same issue. So be careful with the data types. So then I communicate the distance, the ultrasonic distance, through the serial transmit. It's going to be a send mode right, Arduino general transmit serial. Okay. So regarding the wheels, I'm going to put the wheels at a slow speed to avoid, so that the Android phone doesn't fall off the robot. And so this is going to execute only if the command is valid. So we have an enable subsystem in here in Simulink that is only going to run when this is true, when this is valid. So if it is valid, it's going to process the command. So for the case when want to turn off the robot, then I mean stop it, then we can. This is for the light. This is for controlling the light, and this is for controlling the wheels. Notice that the LED is going to use the digital write on pin number 13, and similarly for the wheels we're going to use similar blocks. So you can see the pin number in here. So this is 13 for the LED, and for the wheels is 6, 7, 8, and 9. But in addition to those four wheels pins, we also have to use the enable A and enable B that are always on when we move the robot. So we can just put true to them, but we can put the speed in here. So if we want to stop the robot, we just put 0. It's going to be false, so the value is going to be 0. But if it is true, we want to put the car speed in here to enable A. It's going to use pin number 5. But this is a different controller. Notice that here we have a digital write, but this is different. This is a PWM because we want to control the speed of the robot, PWM. And yeah, so we put the speed in here when it's on. And the same goes for the pin. The first one was pin 5 and this is pin 11. So yeah, it's the same thing. So inside of here, when the command is between 0 and 4, which is controlling the wheels, we're going to enable the subsystem. And this could be a little more simpler with a MATLAB function block, but basically what it's doing is giving the command. So depending on the command that you choose, for example, if it is 0, you're going to enable this, and all the values are going to be false for the enable A, enable B, pins 1, 2, 3, and 4. So in the case of forward, then always this when moving the robot, this enable B, A, and B are going to be true always. So yeah, so it's going to be true for the inner two and false for the outers. For moving backwards is the opposite, true for the outers, false for the inner. And then you have alternate when you want to rotate. This is for moving right, rotating right. So again, true always, and then you have one alternating between true and false. And then for the left, you go into the opposite direction than the previous one. Okay, so that's for controlling the robot. So now let's go to the Arduino, sorry, the Android model. For the Android model, this is the model, and like for the Arduino, you also have to download the Android support package. And I put the documentation of both of them in the description of this link, as well as the link to the robot that I'm using, the Elegoo robot. And yeah, so basically you have an Android support package that's going to provide you these blocks. These are for serial communication. And again, make sure that you have the right data type. In this case, on sign integer 8, sample time is 0.1. The model, as in the case of the Arduino model, also have a sample time of 0.1. And for the serial transmission, actually, no, yeah. So basically, this is going to give you the sonar distance. And based on that, I'm using a stateful chart to implement the logic of the robot. And then the command is going to be here, which is one of these. Oops. Yeah, between 0, move the robot or stop it. And this is going to go to a serial transmit, Android serial transmit block. So this is just for display. So I'm going to display in the, as you can see, as you will see when I'm running the robot, you're going to see in the display of the phone, you're going to see a distance, or sonar distance displaying a graph in here because of this. Okay, so for the logic is very simple. So you start, stop, and then after half second, you're going to move forward, and then backward, stop. So basically move liter by liter forward, and if you detect an object, so by sonar distance being less than 10, then you're gonna move backwards a little bit, and then after that, shortly after that, then you with 57% probability you're gonna move right or move left, and then go back. and keep rotating randomly to left and right until you don't find any more obstacles, and then you keep moving forward and keep moving forward as long as you don't have an object in between. So that's pretty simple. Okay, so now let's take a look at how the robot looks. I forgot to mention that to run this on the Android phone, you just have to do the same. Go to the hardware pane, double clicking here, but first you have to connect the USB cable between your phone and the computer, and then hitting here, and this is gonna compile it, download it, and create an Android application and install it in your phone as an Android application. It's very simple. Okay, let's see the robot moving, and as you can see, this is the cable that the Lego robot has. This is the same cable that you connect to the computer to install the generated code from Simulink from the Arduino model, and then yeah, you do the same with the Android phone. You install the generated code, and both of them have the code right now. Then you can connect them. This is serial communication. I'm using some Velcro to attach the phone in here, and as well as the serial cable, and then you just have to turn it on. So let's take a look. Okay, and now it's gonna execute. It's gonna. There's no wall. There's an object. Okay, once there's no wall, it keeps moving forward. That's it. Okay, let's take a look at how the display looks for the ultrasonic distance data. So this is going to be fed into this display as you saw in the model, and we have also an output for the status, although this is one always. So what I'm going to do is not going to be very visible in this video. I'm going to take the robot far away from the wall gradually, and then closer to the wall, and you're going to see how this affects the number that we're getting here. So I'm putting the robot closer to the wall, and you can see that the number goes down. And then I'm going backwards, and you can see that the sonar distance is going up. Okay, so that is working there. Okay, let's see the robot moving one more time. So it's moving forward because it doesn't find any object in between. And as soon as it's gonna find one, it's gonna rotate randomly left and right, like what it's doing there. And as I mentioned before, this is a beginning for a better project in the sense that you can put more intelligence into this Android phone, like convolutional neural network to detect objects, logic to talk with somebody, basically. Uh, Basically, it could have a conversation with someone or any other advanced logic because the Android phone has the capability to do so. So that's it. Thank you.